And hello, class. As our meeting for the 11th of October falls on what's called fall break here on Monday, the 11th of October, I'm just going to go over some things here via a video to keep us aligned and moving forward this week. So the whole idea with getting this video out to you here is that you'll be able to use the meeting time that would normally go from 6:30 to 9:30 and then some for getting some of this work that we have ahead of us completed. All right. So I'm going to go over this line by line just to make sure we're on the same page here. As mentioned, as this evening's meeting falls on a holiday, we will use the time for completion of the following tasks. Quiz 2 is going to be 3 parts. Okay, so the first part, I've mentioned already in the class, and then the other 2 parts I'll describe here. But parts 1 and 2 use eClass, and part 3 uses Connect. Okay, just to be clear about that, you might want to locate everything first. Okay, so part 1 is submitting Kibbe-Strand 20 complete contracts. Okay, so that should say in Excel. Okay, so that's your Excel file, analysis file. Submit that on eClass orange tab for quiz 2. In Connect, what you want to do is you want to use the the Mod 4 sandbox to gather the necessary information you need to get 15 more contracts. So quiz 1 had 5 contracts that you're stuffed with, or you begin with on Mod 4, and quiz 2 means you have to go in there and look at all the contracts you can and try to get a good variety of them so that you can determine which ones are more profitable and which ones are not. By this point, if you've passed, and probably I think everybody has passed Mod 4, you developed an instinct as to what the contracts were that were the most profitable. What you want to do with your Kibbe-Strand analysis is demonstrate or substantiate that for your final report. We'll talk a little bit about that in the next class, which would be the 18th of October next week. Okay, so you want to go through, and the whole idea here is to complete 15 more contracts. Add that to the 5, you end up with 20. Okay, you need to consider 15 different contracts here. Get a good variety in your sample so you can see what the profitability across them is. And again, one of the keys to succeeding in Mod 4 is figuring out which contracts are the most profitable. Okay, so part 2, you will find an MS Word file that's multiple choice. That's available on the eClass, and that's the orange tab for quiz 2. It's quiz 2, it's orange. And now part 3, you have to go over to Connect, and that part of it is on chapter 17, which has to do with projects, okay? And I will provide video. The idea here is video instruction, guidance. The first 3 questions of part 3 that are, I should say that are in Connect, okay? And I'm going to describe them briefly here, okay? So what we're going to do is critical path analysis, or critical path method, or critical path modeling. Okay, and very briefly, we have a network of potentially parallel activities. You might, as they say, bifurcate after our task A might be discovery mode on a project, and then there might be part B, could be some planning. Okay, and there could be some analysis up here. Okay, and then they'll come together at the end. Okay, so that's activity B, and this would be activity C. I'll try to write over that. This would be our D. Okay, this is just about as simple as you can get. Anything simpler than that would be just 1 task, or it would be 2 tasks, something like that. Okay, and then when you get to 4 tasks, we can bifurcate here, and that introduces some properties of networks of activities. Okay, and so D here. Okay, so D would end up being a final report on something, or we could say even the initial report. It's not even a final report. It could be a launch report or an analysis, a discovery analysis. Should we go no go on this? All right, so that's about the simplest network that you can have. And normally we're fed a table, okay, and we're fed some information, tasks A, B, C, and D, and we're given how much time it takes to get through these tasks, and it might be in seconds, minutes, hours, weeks, months, years, decades. If you're going to send a space mission out to Pluto or something, you have to wait around for 15 years before it gets out there. All right, that's a real project. Okay. And so we end up having the task time, call it TT for my little discussion here. The task time would be X, whatever they are, X, Y, Z, and A, all right, little a. Okay, so we just have some times here that we would look at how long it takes to get through the network. That's the whole thing, time through the network. Okay, so the first problem is we look through here is finding out what the critical path is. The critical path will be whichever path. There's only two paths here. Okay, so we're going to end up with ABD and ACD. There's only two paths here, and one may take longer than the other, possibly. Okay, and that would end up being the critical path. Okay, if you're in one of these departments that's responsible for one of these tasks, okay, they don't really want you to take vacation, or at least they want to have it allocated ahead of time so everything ends on the right date. A, B, C, D, okay? So that's the first case of that. The second case, I'm not sure this is the order the book goes in. The next interesting one of level and complexity is what we call schedule crashing, okay? So schedule crashing. And again, this comes from chapter 17. Okay, and what we do is we do what the normal analysis for this network. Now, the networks that you're going to look at are going to be more complex than that. There's going to be several paths, possibly 5, 6 paths in a set of tasks, or at least 4 or 5. I think the most complicated one I think I've seen is 5, possibly, in any of our work here. Okay, but when we schedule crash, that means once we analyze the network, usually what the question is, how could money change that? How could money change that? All right. If a customer pays, could we speed up any one or some number of the tasks in order to get it done quicker? Okay. So it's generally the way that we think about it most often is, okay, so our standard process is this, and then if someone wants it faster, we'll charge for it because we know how to do maybe task B. We're really good with task B here. We've done enough times, and we have cost-inducing techniques that we could say perform in B in order to shorten the time it takes. So overall, the project shortens. Okay. Now the third version of it has to do with the fact that both in cases 1 and 2, we want to get away from. Okay, so we want to get away from too simplistic approach to a too simplistic approach to these networks where we only have one simple integer number of, say, weeks it takes to get through a task. Okay, and instead of that, what we're going to have is for every task we're going to have what we call the optimistic, which would be the shortest with a label A, and then we would have nominal amount of time that it takes to do it, which is for one reason or another is represented by M, and then we'd have a pessimistic time through there, the long term, like the worst case, if you want to think about that. This would be the worst case, and this would be the best case scenarios, the optimistic and the pessimistic. And we use this, and these processes follow normal distribution, our friend normal distribution. Okay, and there is a way of analyzing this network now where each of these tasks have these 3 numbers. We have a short version of it. The nominal number means kind of the root value of it. I hesitate to say average time through there because that could complicate things. It's the nominal time through there. It's if you had to take your best guess kind of thing. It tends to mean the average, but I want to stay away from that word and concept for the purpose of analyzing that. Okay, so those are the 3 types of networks, and that's the questions 1, 2, and 3 in the quiz. And you can go ahead and try that. But I think you want to wait for me to provide a little bit more information by way of a video here that reviews them. Okay, so that video could easily go 50 minutes, and I actually have to look in my stock of videos that I've created if I haven't done that already. I have a feeling that I might have done that already, and hopefully I did, but otherwise I'll create another video that really tends to this course under its timing for this quiz 2. Okay. So the other things that we'll do this week vicariously, okay, so we won't be together on this, but I will discuss some of the final report details. And next week, week 8, which will be, what did I say, the 18th of October, Monday, the 18th of October, we'll do some of the statistics. You're going to learn in the video, I will explain the statistics needed to do the statistical analysis of what's going to turn out to be a one-sided normal distribution analysis. It's going to be one-sided, okay? And in statistical process control, we'll move over to the two-sided. And all it uses is the same techniques that we used for one-sided. We just get a little creative with it. And we learned a few ways to exploit some of the properties of normal distribution. And between these two, knowing the one-sided and two-sided approach, that'll cover quite a bit in industry, pretty much making you the smartest person in the room. And I'm going to leave the video at this, publish it, get it out to you so you can refer to this. But again, the idea here is to use the time on Monday the 11th that we'd normally be meeting to get at, for instance, part 1 and potentially part 2. Part 1 will probably take you maybe a couple hours to fill that out. Once you get a couple of them going, once you get through a couple more of the contracts, the rest should come easily, maybe not too quickly, because you have to just collect the information for every contract, and it just might end up being that it takes a little bit of time for each one of those, but the idea will be drilled home. By the time you get to that 15th, you will have the idea of this analysis down very well, okay? And I'll cover that in class next week if we have some time, or if not. We really want to get to the part of using Excel to analyze these contracts. But in 8 weeks, we're just kind of clipped here as to how much we can do together, and some of it, which is very important, still has to be delivered by way of perhaps a video, a little bit remote and vicarious here, okay? So I'll let it go at that. I'll publish this and send an email out to you that this has been published, and we'll see it and talk to you soon. Bye for now.